Hello everyone, I'm Dr. Tom Walla, and today we're going to talk about exactly how to do the measurements in the pinyon juniper density lab. What's nice is we'll also be using the same measurements for the spatial lab. So we're going to be using two different kinds of measures to figure out how dense are the trees that are here. Basically, it's going to be a count of the number of trees per area, and we have two methods. Now the first thing we need to do is decide where are we going to sample? And so we've had a little discussion about what is an experimental unit of interest, and that is the habitat of interest. And we're standing in that now. And for example, if you were standing in a giant field or next to a giant field like that one over there, then you would think, well, there's no trees out there. And for whatever reason, probably because of a history of grazing and removal of pinyon and juniper, there aren't trees over there. So you wouldn't sample in that area. It's a huge park-like area without any pinyons and junipers at all. But out here it looks like a forest of fairly large pinyon and junipers we can look at. And the first thing we have to do is find a random point. So to find a random point is actually quite difficult to do. The easiest thing to do is choose a haphazardly chosen point, which is the next best thing to random. But what we mean by that is something that's not terribly biased for being close to lots of trees or far from lots of trees. I'm going to use this Frisbee. I've taken the Frisbee and I've made a little plus sign on it. And I really only needed to label one of these quadrants, but I've labeled four. 1, 2, 3, 4 directions around the Frisbee. I'm going to give it a random toss by doing, and it's going to go out, and where it lands will be the point, and then I can see where quadrant 1 takes off from that particular point. To make sure it's a random toss, and I don't want to be the guy that, oh, I'm going to throw it over there. No. Close your eyes. Watch out for your team members. Spin around a few times to make sure you really don't know where you're looking. And then give it is this a safe direction?
Yes.
Okay, good. I'm going to toss it that way. So I'm going to follow that thing over there, and we're going to see where it landed. Whoa. Let's go find out where it landed. I heard it over here.
It's in the tree.
Oh, excellent. Bad luck today. It landed right in the tree. I'm going to say that if it lands in a tree like that, I'll pull it straight out of the tree and drop it on the ground. And the important thing is I didn't choose any one particular direction. Now I have my Frisbee, and it points to quadrant 1 being that way, all right? First measure we're going to do is the quadrant measure. And in the quadrant measure, I take it back. The first measure we're going to do is the distance measure, which measures the shortest distance to a tree in each of the 4 quadrants. All right? So I can go to quadrant 1. Now I have my measuring rope here. I got this ready before lab. Some people do it in the car on the way into lab. It's pretty easy to make your own rope. You can use a tape measure. What I used was a tape measure. I used 40 inches to mark off the first meter, which is right here. Put some tape or some marker. And that first meter I divided into decimeters or 10 centimeter units. And that way I can measure meters by these large pieces of tape here. So something might be 3 meters long. And then if I'm not sure how long the last little bit of the distance is, I can bring up my little measuring tail, and I can use my measuring tail to get the last distance piece, which will be in tenths of a meter. So you only had to measure the first meter in tenths and the other parts in just meters. Now my whole rope that happens to be 5 meters long, just about exactly. All right. So you can use this in field ecology instead of a tape measure. If you have one tape measure in 5 groups, you can use smaller ropes or string. Just watch out they don't stretch too much. That can cause a problem in measurement. So I'm going to go over here to quadrant 1. Sometimes you got to get down and look for the closest tree in quadrant 1. Now we are not distinguishing between trees here, but I want to measure back to the center of the trunk. Oh, this is great. The center of the trunk where it sits on the ground, and the distance between that my Frisbee. I'm going to go to this point here, that's in here. Trying to have some team members help out. Just about 1 point 1.2 meters. All right, so then I'll have my team members write that down, 1.2 meters. That's for quadrant 1. For quadrant 2, you might be asking yourself, you say, Dr. Wall, this tree's dead, why are you counting it? We have some decisions to make. Should we count dead trees? Well, what I'm going to say is that since we're looking at tree density, and we're looking at how many fit in a space, this tree is probably only recently dead based on these needles, which means it hasn't been time for another tree to fill into that ecological space to use those nutrients. So I'm going to say, yeah, I'm going to count this tree because probably last year it was alive and it was occupying this space. So if you got a really dead tree that has young trees growing around it, maybe you don't want to count that one. But I'd say most of the dead trees that actually have needles on them are recently dead. So I'm going to go here to quadrant 2, which is this way, and I'm going to look for the nearest tree in quadrant 2. This is a little bit tricky because I got a line coming through here which goes that way, and a line going out there which goes that way. So I'm pretty much looking anywhere out here, and it looks like it's that tree there. So now I'm going to go from my Frisbee. Easier if you have some group members to help you out. That's 5 meters to here. Mark that with my foot. Next distance is, maybe I'll put this little stick here. Measuring right out to the middle of the tree. It's a big trunk on this one. Looks like about 5.123. 5.3, sorry, not 5. First 5 meters, and then we add 1 meter, 2 meters, and 3/10. So that's 7.3 meters to the nearest tree, okay? We did that for the first 2 quadrants. We'll do it again for quadrant 3. Going this way. That one's going to be pretty easy to write on that tree. We'll do it again for quadrant 4, which will be this way. On quadrant 4, we have some questions to ask. I follow that line out there. Quadrant 4 includes this little tree. Now I've got a decision to make about this little tree. We have a cutoff of 1 meter high. And rules be rules, this tree is a lot taller than 1 meter. 1 meter is about that tall. Oops, not that tall at all. Let's try that again. 1 meter is about as tall as the tape. This is clearly over the 1 meter mark. So we're going to count this tree. All right, even though it is pretty small. So it'll be the distance to this tree from the Frisbee. That gives us 4 numbers. That's the end of the distance measure. Now we're going to do a quadrant measure, taking different kinds of data in the same location. Also a randomly chosen point, but instead of looking at the distance to trees, we're going to measure a 5x5 square quadrant, count the number of trees in it. Now, my trusty rope is 5 meters long, a little tricky to measure right through that tree. So instead of crawling through there and making a mess of things, I'm just going to go over here and measure parallel to that line, and then move over 2 meters to get a good estimate of what a 5 meter climb looks like. Now, here's a trusty rock I can use. And it's about 5 meters there, so it should be straight out from my Frisbee. That rock marks 1 corner. I like to do the 2 off of the Frisbee, so I'll go over to the other side of the Frisbee. Again, instead of crawling through the tree, you can just lay the rope down 3 feet outside the tree and then step back in when you're done making your line. That one goes all the way to out here. And if I put that, there's a rock there that will mark that point. Now I can pretty much eyeball the rest of this. If there's any questions, I'll run this rope from here. That's my rock over there. So this is a square. You don't have to measure every side. If there's no tree here, it's pretty clearly not going to be a problem. It looks like in this quadrant, quadrant number 1, I've got some trees. Let's see, I've got this big juniper here, and I've got that dead pinyon there, which I already counted once, so I'm going to count it again. That is 2 trees in my quadrant. And I only do 1 quadrant for each point. So that's a 5 by 5, which is 25 square meters. Now I've collected the 2 types of data. 2 trees in my quadrant, and I have 4 distances for my distance measure. I've also had to resolve problems. Do I measure to the tree edge? No, I measure to the center of the trunk where it meets the ground. I also use that point to decide whether it's on one side of the line or other, so what quadrant it belongs in. And I've saved myself the trouble of charging through the middle of trees by measuring around them, stepping in on the other side. So we also have the rule we follow. We don't measure trees that are shorter than 1 meter, but we do measure ones that are taller. And the most important thing is that if it's longer, so in the quadrant you can get a 0. But sometimes if you're doing the distance measure, you don't get a 0, like you're on the edge of a meadow maybe, and maybe there's no trees out there for the next 10 meters. And if you don't see any trees for 5 meters, you don't see any trees for 10 meters, we're going to use 10 meters as the maximum distance. That's 2 rope lengths of your rope, by which you would say there are no trees. The reason for that is that if you have to go 100 meters to find a tree, that 1 data point will completely change your measure of the density in that forest. So we're going to use 10 meters as the maximum for a distance, for the distance measure. Okay? Let's get some data.